Hello everyone. Welcome back to now the third installment in our probability review. So far we've covered just some basic probability terms, and we've also covered some conditional probability. In this video, we're going to cover specifically the discrete probability portion of this unit. Now, this is a very generic term, but I think you'll see essentially what this covers is expected value and how to use it. So let's jump right into it. Let's take a look at some of the formulas, which again are on your formula sheet. But more specifically, let's take a look at some of the example problems that you might see in this, or that deal with this particular topic. So expected value, all it is the mean of a probability distribution. So it's essentially like, think of it in easier terms. Think of this as just a weighted average. That's all it is. A GPA is a example of an expected value. But that's all it is. And so the formula for it looks exactly like that. It's a summation sign of x times the probability of x. So I'm going to essentially multiply the thing times the probability that it happens and add them all up. That's it. And so the other thing that's important here, how do we interpret expected value, is that it is in the long run. I would expect, right? And now we fill in the context. And I'll put this also in the context of the problems that we're going to look at coming up. But let's say you compute it. It's like a carnival game, right? And you compute the expected value to be $2. Well, that means in the long run, I would expect to make on average $2 per game, right? Because most of the time it's like you pay $5 to play and you either lose it or you win a certain amount of money. Right? Like, it's not possible to win $2 in a game, but in the long run, I would expect to make that much on average. So if I played the game 10 times, I would expect to make around $20, something like that. So let's take a look at some of the examples here. And if you're from my class, you will absolutely recognize this question because it was something that I put on a weekly assignment, right? And so we have these two different courses of treatment with antibiotics. And again, it's a tree diagram type question, but either way, right? It's for part A here. It's essentially like we're going to treat with A first or B first, and if that doesn't work, then we're going to move on to the next thing. And so I believe antibiotic A works 60% of the time, antibiotic B works 90% of the time. And so for plan 1, which is when we start with antibiotic A, we're either cured with A, or there's a 40% chance that I have to use B, and then a 90% chance that my ear infection is cured with B. So this gives me a 96% chance, if you will, of being cured. For plan 2, I start with B first, so then there's a 10% chance that I end up having to use antibiotic A, which, not so surprisingly, also gives me a 96% chance of being cured. This should not scare you if this happens to you on the exam, because as we go through the rest of this question, you're going to see the next part is they're going to ask you to compute the expected costs for these plans. So when I see the calculate the probability of being cured and then calculate the expected cost, I'm expecting one of two things. Either one, the probabilities are going to be the same and one has a lower cost, or two, the costs are the same and one has a higher probability of curing me. So I'm looking for one of those to be the same number and then one of those to be different. Because if the cheaper plan is less effective and the more expensive plan is more effective, how do you make a recommendation that the AP graders can grade? It's impossible. It just means everybody's right no matter what. And so when I look at a question like this, knowing in my head that there is one correct answer, I am expecting one thing to be the same and one thing to be different, and then that's how I'm going to make my recommendation. So in this particular case, the fact that it was a 96% cure rate for both plans, I'm actually really happy right now that I got the same answer, because it probably means that I'm on the right track. Now, if we look at part B, oh, okay, so now let's compute the expected cost. Now, if we take a look back at the question, antibiotic A costs $50, antibiotic B costs $80. And so, if I take a look at this, right, for plan one, we start with antibiotic A, so I know I gotta pay the $50 up front, and then there's a 40% chance that I gotta pay the $80 for antibiotic B, right? Maybe A doesn't work. This comes out to be $82. So again, this is plan one. Plan two, I pay the $80 up front, and then there's a 10% chance that I have to pay the additional $50. Oh, wait a minute. That works out to $85. Ding, 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 right? This should be something where now you're like, okay, I got this question right. Because I got the probabilities were the same, but plan one was cheaper. And so when I look at part C, based on your results, what would you recommend? I'm going to recommend plan one because it has a lower expected cost and the same effectiveness as plan two. Right now, interpreting this $82, if they asked you to do that, that would be in the long run. So, on average, for every child with an ear infection, if we added up the money spent on antibiotics, we would expect it to be around $82 per child. Because some kids are just going to have to pay the $50 for antibiotic A. Some kids are going to have to pay $130 and get both A and B. And so, right, it's impossible for one person to spend $82. But if I look at all of the money spent on antibiotics A and B for all children with ear infections under plan one, I would expect that to average out to about $82 per child. So that's how we would interpret that. Now, the other type of one you might see here, I'm not going to go through this whole question, but essentially this is like the guessing penalty question. You get 1 point for a correct answer. You get no points if you leave it blank. And then you lose a quarter point if you get a question incorrect. Right? And so we're just going to take a look at part B for this particular one, right? Which is, suppose that they know the correct answer for 18 questions, and then we're going to guess on the other 7. And it's literally telling you to show that the expected value of the score is 18. So essentially, they've gained nothing from guessing if they know these things. So for this particular one, again, same idea, just for part B. I know the answer to 18, so I know I'm going to get those points. Plus, okay, on those 7, right, my expected number of points is 7 times 1/5, right? Because that's my expected gain. Now my expected loss, right, is 7 times 4/5 times 1/4. This is the 0.25 points lost, right? Which is why I'm subtracting it. And so when you actually work this out, it's very, very simple here. It's 18 plus 7/5, and then these cancel out, and so I just get minus 7/5, which equals 18. Very simple, very straightforward. I included these 2 examples because these are the ones that are a little bit more complicated and are less obvious to use. Some of the ones are very straightforward, where you're given a table and it's very straightforward and easy to do. These were the types of questions where you had to think a little bit about the expected value process. The other ones where you're given a table and a probability, it's very straightforward. Just multiply across, add it all up. These were the ones where you had to think a little bit. So again, I hope that was helpful, and I'll see you in the next one.